So welcome to my talk, which will be about performance tracing and observability in React Native apps and native code. I'm a senior React Native engineer at Callstack, in short. And first, I would ask the question, Varum. Why do we even care about performance? And one of the reasons is UX. So the loading bars you see to the right are probably one of the most annoying artifacts to the users of your application. And why does that matter? That's because it has a direct impact on app rating, which in turn influences adoption. So if you see poor grades such as this one that is displayed here, or opinions about your application such like this one, then it's very unlikely that your app will gain greater adoption. And there are a few factors that influence this, this phenomenon. So this figure comes from our Callstack blog, and one of the items here is lengthy lists that are slow or flicker. So this is a very well-known issue in optimization. There is also an issue that is React Native specific, so passing inline props or objects that are not referentially stable across renders, which in turn causes unnecessary renders. And this is one of the biggest problems that we may be able to see here. So unnecessary renders that are one of the major culprits here. There is also state management, so this is a bit more complex. It has to do with other external libraries. And finally, we have one of the key factors, that is TTI, so time to interactive. If it's slow, basically the first experience of the user with your application will be poor, and they will be highly discouraged to judge this app positively. And the second question is how are we going to optimize? What can we do about it? And one of the answers is DMake methodology, which consists of a few steps. So the first is define. We define a performance issue. What is the performance issue for us? Is it that the screen takes above 300 milliseconds to render because it's a large, very complex screen, maybe some rendering involved? Or is it a very simple screen and above 30, 50 milliseconds is not good enough for us? Then we have the second stage, which is measure. So we set some baselines. So for instance, we measure for the first time, we capture the render time of the screen, and each time we actually iterate, we bring some new features or fixes. We ensure that by the time, by chance, we didn't introduce something that actually alleviates, that makes it even worse than it was, maybe in some unexpected place. Then we have analyze. So after we measure, we compare, we can walk away with some actionable items that we can improve on, and this is the next thing. So we choose the ones that actually have an impact and are important for us. And then we can improve, optimize, and finally, the last step is control, which means that we won't come back to the first square, we won't start over. So the improvements that we gain once are not lost in the meantime as we progress with our development. And there are certain ways, several ways to do it. One of them is by, for instance, integrating with CI. And there is an open source tool that's called Reassure that was also authored in at Callstack that allows you to actually keep track of this. So it allows you to easily keep track of the metrics, and you can even automate it by integrating with a bot on GitHub that will allow you to continuously keep track of this automatically, for instance, in your PRs, to make sure that you don't worsen some of the metrics that you set up. Then we go to another topic, which is production-grade performance monitoring. So you may be interested in doing things like telemetry or observability at production. That will allow you to actually monitor some performance indicators of your application, let's say spot it in the wild in different various environments, in different setups, in different configurations, maybe based on the fact that the user is running on a low-end or high-end device. Maybe they have some edge case that you didn't capture earlier and you didn't think of. So all of this allows you to capture the statistics of those performance indicators in the wild, in reality. And you can even aggregate them based on some filters you set up. So this all depends on the metadata you capture. And one of the solutions that you can use is OpenTelemetry. So it's an open source project that has its own protocol called OTLP, OpenTelemetry Protocol. And you can integrate various tools to preview it, such as the one presented in the background, which is Jaeger, that can visualize, store, aggregate this data. There are also other solutions that provide equivalent or very similar functionalities. One of them is Embrace. So this is a company, this is a commercial solution. However, its React Native SDK is open source. It's built on top of OpenTelemetry, what's more. You can find it on GitHub. And the commercial part is that they offer a cloud where you can view processed aggregated data with some insights. And it's pretty similar to another alternative, which is Sentry, that allows you to do something very similar on their end. However, the SDK, which is, by the way, of course, also available for React Native, is not built on top of OpenTelemetry. And what about the development tools? Because we have now spoken about the tools we can use for production-grade monitoring. But there is also, and of course, not mentioning Reassure, which allows you to do this in-house, but in an automated way. But what about the tools that you can give your developers to actually keep track of whether their changes do improve something or do break some metrics? And first, I will iterate over a few items that you can trace, that you can monitor. That is components and hooks, so we can trace how long, how frequently do they re-render, do they cause re-renders to other parts of your application. Then there is networking, so you can keep track of the success rate in your requests, the average length, the maximum length of those requests. And finally, there is navigation, so usually, especially when you're doing some production-grade monitoring like observability, you will want to be able to easily, or maybe not easily, but able at all to reproduce what your users did. So for this, you will probably want a solution that will allow you to trace what they did in the app when navigating between screens. And there are other tools for developers, for instance, Flashlight. So this is a free tool, an open source tool that allows you to plug into any Android application, not even React Native specifically. And it doesn't require any setup on the application side. You just attach it and grab the metrics. And the metrics can be grabbed multiple times, where you will get a comparison between different runs, usually of the same app. This is why it makes sense. And you will be able to compare side by side different metrics such as RAM usage, FPS, total CPU usage, and CPU usage per different threads, including the React Native JS thread. So this will allow you to easily identify, let's say, broadly where the culprit may be. So is it in this part of the recording? Is this screen? Is it JS? Is it native? Is it maybe out of memory? And there are even more. So there is a React Native performance library that's also available on GitHub. There's a link under the figure. And this one allows you to programmatically also do some tracing. There's an API for JS and an API for the native languages. And this allows you to fetch programmatically the metrics that are obtained using this tool. It also integrates with Rosinite, which is a GUI for development tools from CallStack. And yeah, you can preview this visually there. Finally, there are also some built-in solutions into React and React Native that you don't need to actually do anything to use. So there is, for instance, React DevTools that you can attach to a development build of your React Native app that allow you to trace why did a component render, how long did it take, what was the reason, was it props, hooks, context, if so, which one. There is also React Native DevTools. This is pretty new to React Native. Under the hood, it uses the Chrome debugger protocol. So you actually, the GUI you see is actually the Chrome DevTools with some extensions. And this allows you to view the JS debugger, inspect, pause, step over, view console logs, and the components tree, of course. Finally, there's a new feature that was announced recently on the React Conf, that is React Performance Tracks. So these will allow you to keep track of why did components re-render, but in a different view. To keep track of scheduler tasks, so this will show you the internals of React Native, what task was being scheduled, why, what did it do. The component re-render part will also be split into the different phases that we know that React involves. And there is also a separate track for server components if that is included in your use case. And the last question I wanted to ask is, can you use native tools? Because some of them, or many of us here, could be more, could have a more native-oriented, let's say, spectrum of interests. So in this case, yes, the answer is yes, you can use native tools. React Native under the hood even has an integration, but for its internal in-house development purposes and when the React Native is packaged so that you can actually consume it in your application, this is disabled and stripped. But there is a way you can use Android Studio Profiler, Perfetto, or maybe Xcode Instruments, or maybe even third-party tools such as this one, which is Tracy, an open source profiler available on GitHub. And for that, you may consider to either, of course, implement it yourself, it's certainly possible, or you can use a library that we created at Callstack that's called Ottrelite, and it allows you to trace events and preview them in any of those tools that I mentioned from both JS code, native code, and by native code I mean C++, Kotlin, Java, and Swift or Objective-C, because the whole implementation is in C++. And the way it could look in practice is as follows. So this is a demo app that I had created earlier. Here we have Android Studio and the Android Studio Profiler, and we can try to actually record some events from here. So this is a screen that renders a dummy image here in C++ from a C++ Nitro module. Here the same functionality but from Kotlin. And to the left we can see the captured events via Ottrelite in Android Studio Profiler. Here are the phases. The tiny boxes at the bottom are actually individual rows of the image during generation. And you can see that traces from all languages were captured in between. And here you can plug in any backend. You can even write an implementation for your own. And in general, for this and pretty much any other library that you may want to use for such tracing, the idea is very simple. So you start an event, or sometimes this is called a section, at some stage in your code. And finally, when you complete an operation, whether it's synchronous or asynchronous, maybe even happening across different threads, you call end. You can usually or sometimes attach some optional metadata in the form of a key value object or anything like that. And here is an example that does this with Ottrelite in first C++ and now in Kotlin. And finally, a short summary. So I will reiterate what we actually browsed in this, talked about in this presentation. So first we had the development tools. They were mostly JS only, so, or maybe not even JS only. I had to somehow put them into common boxes. Flashlight is a bit different because it's not related to JS or React Native at all, but it allows you to trace maybe get an overview of the performance of any Android application. Then React DevTools, React Native DevTools, and React performance tracks, they are built in, so they come out of the box. You can easily use them, but they are development only, at least DevTools. And there is also a category for development JS plus native, so you also have an API that you can call from the native languages, for instance, from your native modules. Maybe this could be some video player that you're trying to debug the performance of because it's degraded. Maybe the video decoding is not working as you would expect it to. So here you can use React Native Performance or Ottrelite. And in production, I will start from the end because it's a different category. For some, it's not maybe production, but it's still a development, but not in the development build, but CI automation on the server. So you can use Reassure to keep track of the metrics before, for instance, you merge a PR to ensure it doesn't break some metrics in an unexpected place. There is also OpenTelemetry, that is a completely open source tool, let's say not tool, but standard and protocol. And it also provides the SDKs for multiple languages, including React Native, and technologies, including React Native. And you can integrate a tool of choice from a pretty wide variety of tools to aggregate, to collect, and preview the data from OpenTelemetry. Finally, there are either semi or just commercial solutions, which is Embrace and Sentry, that do pretty much the equivalent, but also offer some hosted cloud panel to aggregate, store, preview the data, plus some insights and analytics. So I hope that with this image in mind, it will maybe help you choose or improve the way you collect data, you work on this data, and improve your applications. And thank you for your attention. Danke und tschüss.